Hello everyone! I am Miss Lea Lebite and I will be your teacher for today's lesson. Our goal is to explain the properties of solids, liquids, and gases based on the particle nature of matter. To start with, I will show you different samples of matter and I want you to classify these matters as solid, liquid, or gas. Here's the first, second, and the third samples of matter. Correct, that is solid, liquid, and gas respectively. Now, what made you say that rock is a solid, water is a liquid, and that smoke is a gas? Very good, because of their properties. Today, we are going to discuss the different properties of solids, liquids, and gases. And these properties can be explained by the kinetic molecular theory of matter or the KMT. First, kinetic molecular theory states that all matter in any state consists of very small particles that are constantly moving. Second, since the particles are in constant motion, they therefore possess kinetic energy, the energy associated with motion. Third, particles interact with each other through attractive and repulsive forces. These particles therefore have potential energy or stored energy. However, attractive and repulsive forces are negligible for gases except at very high temperatures. Fourth, the kinetic energy of the particles increases with increasing temperature. This is manifested by faster movement. Lastly, there is no loss in the total kinetic energy when the particles collide with one another. Energy may be transferred and kinetic energy may be transformed into potential energy and vice versa. Again, this theory explains the properties of solids, liquids, and gases. Now, let us discuss their properties. First, let's talk about the properties of solid. In solid matter, particles are tightly packed. Thus, forces that hold the particles are strongest. This is the reason why most solids have greater density and have a very high boiling and melting point. They vibrate, but they are not free to move around. Since the particles are very close to each other, they are difficult to push even closer, which means they cannot be compressed. These properties explain why solid matter has definite shape and volume. Most of the materials we are using are solids. Examples are woods, tiles, books, pens, and a lot more. Solids also exhibit properties that are unique. Examples are ice cubes. Ice cubes are water in solid form. Although we know that solids usually have greater density than liquids and gases because particles are closely packed, solid like ice cubes can float on liquid water. This is because the density of the ice cubes is lesser than that of water. Ice cubes having a density of 0.9 gram per milliliter, while water having a density of 1 gram per milliliter. Another unique property of solid is that it may exist in crystalline form. This is a solid whose atoms, ions, or molecules are arranged in an orderly, geometric, three-dimensional structure. Examples are salt and other rock minerals like quartz. The individual piece of crystalline solid is called crystals. Other solids exist in metallic form. This means They consist of positive metal ions surrounded by a sea of mobile electrons. These mobile electrons make metals good conductors of heat and electricity. Copper is an example. Lastly, we have the amorphous solid. This solid is formed when metal cools quickly to allow enough time for crystals to form. Examples are rubber and plastic materials. Next are the properties of liquid. Liquid matter is made of more loosely packed particles than solids. This is why intermolecular forces of attraction between liquid particles are weaker than solids. This also explains why liquids have only high boiling and melting point, compared to solids having very high boiling and melting points. Particles move or slide past each other because there is little free spaces between molecules. This is why liquids do not have definite shape and take the shape of the container, but they are packed densely enough that their volume is maintained. Generally, they are less dense than solid. Water that we drink, honey syrup, cooking oil, and glue are examples of liquid. Just like solids, liquids also exhibit unique properties. One of its unique properties is called fluidity, or the ability to flow. Generally, all liquids have the ability to flow. Water is our common example. Another unique property of liquid is viscosity. Viscosity is a measure of the resistance of a liquid to flow. It is determined by the type of intermolecular forces involved, the shape of the molecules, and the temperature. The stronger the intermolecular force, the higher the viscosity. Honey syrup is an example of liquid with higher viscosity. This is because large chain of sugar molecules slides past one another, making it difficult for the liquid particles to flow. Next property is surface tension. It is the energy required to increase the surface area of a liquid by a given amount. It is also a measure of an inward pull by particles in the interior. The stronger the attraction among the particles, the greater the surface tension. An example of this is the paperclip floating on water. The high surface tension in water helps the paperclip to float because molecules of water can form multiple hydrogen bonds. Lastly, we have capillary action. It is the ability of a liquid to flow in narrow spaces without the assistance of or even in opposition to external forces like gravity. It occurs because of the intermolecular forces between the liquid and surrounding solid surfaces. Example is the paper chromatography, in which liquid particles move in a porous material. Then we have the properties of gas. Gas particles are far apart from each other, allowing them to move very fast in all directions. That is why intermolecular forces of attraction between gas particles are generally weak. Thus, they have a very low boiling and melting point. Gas particles are highly compressible because they are far apart from each other. This is also the reason why gases do not have definite volume. Gas molecules are in continuous motion, and they frequently strike the walls of their container. The more gas molecules present in a container, the more frequent the collision with the side of the container, the more force against the side of the container, which results to greater pressure. Collision between gas molecules is said to be perfectly elastic. That is, collision without loss of energy. Pressure is the force exerted by the movement of molecules over the area. It is equal to the amount of force per unit area. This factor affects the properties of gas. Another factor that affects the property of gas is temperature. A change in temperature affects the volume and pressure of a gas. An increase in temperature causes a gas to increase its volume. Why? Because the increase in temperature can cause an increase in the kinetic energy of gas molecules, making them as far as they can, creating greater distance from each other, thus making the volume to increase. A decrease in temperature results to a decrease in the volume of a gas because of decreased kinetic energy of gas molecules, causing them to come near each other, thus decreasing the volume the gas molecules occupied. Temperature is directly proportional to pressure. In a fixed volume of a gas, an increase in temperature will increase the pressure, and a decrease in temperature will decrease the pressure. Temperature is a measure of the average kinetic energy of the particles in matter. Air that we breathe, helium gas used to inflate balloons, and vapor from boiling water are examples of gases. Now that you know the particle nature of matter, let us differentiate solids, liquids, and gases in terms of their mass, volume, boiling and melting point, density, and specific gravity. Mass is defined as the amount of matter in an object. Volume refers to the amount of space occupied by matter. Boiling point is the temperature in which vapor pressure of liquids equals the pressure surrounding the liquid and the liquid becomes gas. Melting point is the temperature at which solid changes to liquid. Density is a measure of how much mass of a material fits into a given volume, while specific gravity is the ratio of the density of a substance to the density of water at 4 degrees Celsius. From our discussion, how will you differentiate solid, liquid, and gas in terms of their masses? Correct. Solids, liquids, and gases all have definite mass. How about their volume? Very good. Both solids and liquids have definite volume, while gases do not have definite volume. What about their boiling and melting point? That's right. Since strong forces of attraction holds the particles of a solid, very high temperature is needed for them to reach its boiling point and melting point, while high temperature is required for liquids to reach its boiling and melting point. And since gas particles generally have weak forces of attraction, its boiling point and melting point are very low. Lastly, what can you say about their density and specific gravity? Very good. Because solid particles are tightly packed, they have high density and specific gravity compared to liquid with an average density and gas with low density. With what you have learned today, I am confident that you can now explain the properties of solids, liquids, and gases based on the particle nature of matter. And that ends our lesson for today. You may now answer your module, Week 1 and Week 2. Enjoy and have fun learning!